I know, I don't want to do it either, but you know what? It's good for us to do it because it keeps all of the stuff fresh. So one day a week we're gonna go back and we're gonna like cycle back, and then we're gonna keep going forward, and then we're gonna cycle back.
You know, that also makes me like confused.
It's one problem. It's one problem. Okay?
That's
So find me the equation of a parabola with a focus at -3, 4 and a directrix at y equals -6. The nice thing is that you have taken such great, grand, and wonderful notes that you can easily look back
up. Yes, I do. Hold on.
Okay. All right. I'm just going to draw the scenario, just so you know. Okay? So here's our Cartesian coordinate system. Thanks, Rene. Okay? That's Rene Descartes, by the way. He's the one that invented it. Okay? We got a focus at -3, 4. So that would be up in here. Already don't like that F. Okay. We got a directrix at y equals -6, just so you know at least I'm doing the problem. I just wrote it down, and that's it. Okay. Okay.
Wow,
Which way does it open?
You can lift it really well.
I know I can. Which way, Julia? What you got? Opens up. Love it. Okay. So if it opens up, that means our equation is going to look like x minus h quantity squared equals 4p, and that 4p is going to be positive y minus k quantity. Okay. So that's what our equation is going to look like because it's an up opening parabola. Okay. So next thing we should probably find is our vertex. And our vertex is going to be located right there, and that is going to be at the point -3, -1. And the reason for that is there is a distance here of 10 between the between the focus and the directrix, which means that the distance then from the vertex to the focus would be 5, and vertex to directrix would be 5. We've cut that distance in half. So we got that. Which also means that 5 is our p value. Yeah? So that we can all put into the equation then as x minus -3, because that's our vertex, so that's going to be x plus 3 quantity squared, equals 4p. 4p is 5, so 4 times 5 is 20, times the quantity y minus -1, which is y plus 1. So that is the equation of the parabola with focus at -3, 4 and directrix at y equals -6. Possibly. Yeah? Good? Great, grand, and wonderful. Today we're going to move on to our next topic. And our next topic is, come on group. Only section 3. Not section 4. Okay. And our next topic is that of an ellipse. So, an ellipse is a curved line forming a closed loop where the sum of the distances from 2 points, which we call the foci, to every point, this shouldn't say on the line, but it should say on the ellipse, is a constant. Okay? So I found this website, and the reason I like it is because, so what an ellipse basically is you take a circle, okay, and you pull it. You stretch it out either horizontally or you stretch it out vertically. Okay? So it's like an oval. Okay? Right? So that's what we do with it. But the kicker is that we're going to have these 2 points here called the foci. Okay? And those foci, the distance from any point on the ellipse, okay, that distance is going to be constant. When we add those two distances together, it's going to be constant all the way through. Sometimes B is bigger, distance to the second foci. Sometimes A is bigger, but when you add those two numbers together, you get a constant term. Okay? Sometimes they're equal, somewhere up in here or down here, they're equal. Okay? But most of the time, one is bigger than the other, and it goes all the way around. Okay? That is how we come up with an ellipse. Okay? The equation for an ellipse is here. Quantity x minus h squared divided by a squared plus quantity y minus k squared divided by b squared equals 1. Ellipses always are equal to 1. Okay? Always, always, always equal to 1. One major condition is that A cannot equal B. Because if A does equal B, then A squared is equal to B squared, and then we have a circle. Yeah? So that is why A cannot equal B, because we don't want to be a circle, we want to be an ellipse. Okay? Now, in-personers, I don't know where you're at with graphing paper, but if you need graphing paper, there's always more up here on the desk. But we are going to have 2 graphs today. Okay? So, a couple of real-world examples of ellipses. Orbits of comets, orbits of planets around the sun. They are in an elliptical fashion. When I'm looking at the water that's in my glass right now here in front of me, or if I'm looking at my Gatorade bottle in front of me, when it's vertical, it's a circle. But when I tip it on its side, now it becomes an ellipse. Okay, that's one. The planetarium in St. Louis has a ceiling that is in the shape of an ellipse. That's this upper right-hand picture up there. Okay. These other 2 here are pretty cool. So first off, the one in the lower right-hand corner, that's St. Paul's Cathedral in London. Okay. It is in the shape of the room is an ellipse. Okay. The original U.S. Capitol building had an elliptical room, okay. And John Quincy Adams found that when he was a member of the House of Representatives, way back long ago, he discovered an acoustical phenomenon, and that was if he was standing at one of the foci, he could hear all of the conversations going on at the other foci. Because of the way that from the foci, the bouncing off of the sound waves off of the walls and the ceiling. Okay? It works out. If you're in an elliptical room, okay? You can be at foci. Okay? I think the Science Museum in St. Paul has an elliptical room where you can do this phenomenon, and you can there's a bunch of stuff going on around you, but if you're standing at either foci, you could have a conversation, even if there's tons of other stuff going on. Okay? All right? So let's get into one. Let's go. This is the example that we are going to do. This is the first example of the day, first of 2. Okay? And so here is an ellipse. Quantity x minus 3 squared divided by 9 plus quantity y plus 2 squared divided by 16 equals 1. That is an ellipse. Okay? First thing that you, yes you, are going to want to do is you are going to want to find the center. So we want to find the center. Just like with circles, just like with parabolas, we remember that we are thinking oppositely inside a set of parentheses. So I'm looking here and I'm looking here for my center. With that being said, what is the center of this ellipse? Ms. Galligan? Do we agree with 3 comma negative 2? Okay. All right. This patent has given me the thumbs up, so I'm going to go with the fact that it is located at 3 comma negative 2. Okay. So what you would want to do then is on your graph, you would want to go to the point 3 comma negative 2, and you would want to put a C there for the center. Step number 2 says, now what we're going to do is we are going to look at the number underneath the x squared term. In this particular case, that means we are looking at the number 9. That is going to give us the endpoints of the left and the right side of our ellipse. So we're going to take the square root of that number, and that's how far left and how far right we're going to go. Well, what's the square root of 9? 3. So I'm going to go to the left 3, 1, 2, and 3. I'm going to go to the right 3, 1, 2, and 3, all from my center. Okay. Good so far. Next, what we're going to do is we are going to look at, we are going to look at underneath the y squared term now, and we are going to again take the square root of that. What's the square root of 16? 4. And so that tells me that I'm going to go up 4, 1, 2, 3, and 4, down 4, 1, 2, 3, and 4. Okay. This has now given me the framework for my ellipse. Okay? So we can draw in the ellipse now. Okay? So I'm going to draw in my ellipse. Pretty good ellipse, I've got to say so myself. Okay? So there is my ellipse drawn in. Again, not straight on the sides, okay? Curved as best you can. Questions so far? Okay. Awesome. Part of what we're going to have to find are something called the vertices. The vertices of the ellipse are the endpoints of the major axes. Well, the major axes is the longest of the ones. the minor axis is the shorter. Yeah. They're either going to be your major or minor axes are either going to be vertical or horizontal. So if I go back up here and I look at my ellipse, I'll do this one in blue. Okay? This is my minor axis because it is shorter than this one, which is my major axis. So the vertices of my ellipse are the endpoints of that. So the vertices would be here. That would be the point 3, 2. And down here, that would be the point 3, -6. And those two are my vertices. Part of what you're going to have to find are the vertices every single time. Then lastly, what we're going to have to find is we are going to have to find what is called the foci. Okay? So remember, there's not one focus like there was in a parabola. There's two foci. Okay? Foci is the plural focus since there's two. They are located on the major axes. Okay? Remember, major axis is the line across the ellipse that is stretched out the most. Okay? So they're going to be on, in this particular ellipse, they're in the vertical position. Okay? The most important formula for foci is this one right here. C squared is equal to the absolute value of a squared minus b squared. C squared is equal to the absolute value of a squared minus b squared, where c is the distance from the center to that, or those foci. And sure, we can. There it is. Where c is the distance to the foci. Okay. A squared is the number that we have in our original equation underneath the x squared, underneath the x term. B squared is the equation or the number that we have underneath the y term. Okay? So, refreshing our memory, this is x minus 3 quantity squared all over 9 plus y plus 2 quantity squared all over 16 is equal to 1. That is the equation of our ellipse that we're graphing right now. So in this particular case, a squared is 9 because 9 is underneath the x term. B squared is 16 because it's underneath the y term. So c squared is going to equal the absolute value of 9 minus 16. 9 minus 16 is -7. Absolute value of -7 is +7. Okay? So c squared is 7. Square root both sides to solve it. So that gives me c is the square root of 7. since our major axis is vertical, that means we're going to add and subtract C to the y part of our center because the number was bigger underneath the y. Another way of remembering. This number right here was bigger, so that means we're going to add it to the y part. Add it and subtract it. So our focus here is at the point, remember that our center was at the point 3, negative 2. Okay? So I'm going to add and subtract the square root of 7 to the negative 2 part. And I'm going to leave it in radical form. So the two foci are located at 3, negative 2 plus the square root of 7, and 3, negative 2 minus the square root of 7. So, putting it all together then, okay? So the steps that you need, oops, I guess I gotta raise these up a little bit. I thought I could get those all on one. The steps that you need to do in order to graph an ellipse, or if you're answering questions about an ellipse and things that you need to find about said ellipse. Okay? So first off, you're going to find the center. Then you're going to look underneath the x part to give you your left and the right. Then you're going to look underneath the y part to get your up and your down. That is going to allow you to draw it. Then you can find your vertices and points of the biggest or the longest side, or longest axis. And then find the foci. C squared equals the absolute value of A squared minus B squared. Okay? So there are 6 things that you have to answer for every single question. Okay? First off, you're going to graph it. Then you're going to tell me the center. Then you're going to tell me the 2 vertices. Then you're going to tell me the 2 foci. Okay? So 6 things to tell me on every single one. Okay? So I want you to graph this particular problem. I want you to then tell me, list out what the center is, the vertices, and the foci. Go for it. All right, so what do we get for a center? What do we have? 1, negative 2? Okay. 1, negative 2, center right there. Love it. Okay. Left and right, what do I go? 5. 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. Okay. Up and down, what do I go? 2. No. Up 2, down 2. So we've got that. Yes. Okay. That should allow me to draw in looks more like an egg, but we'll let it slide. Okay. What we got? Huh? Yeah. That gives me these 2 points as my vertices because horizontally it's longer. So that would be at the point negative 4, negative 2. And 6, negative 2. Agree with those? Yeah. Then I need to do my foci work. So C squared is going to equal the absolute value of 25 minus 4. 25 minus 4 is 21. So C is going to be the square root of 21. Yes? Okay. So since my foci are going to be the square root of 21, which is just over 4, about 4.5-ish, 4.5 to the left and 4.5 to the right, that means I'm going to add and subtract them to the x part of the center. So my foci would be at 1 plus or minus the square root of 21, comma, negative 2. And that is the 6 things that I need in order to graph my ellipse. What do you got?
I don't understand. Wait, so why is that?
I did it in a different order.
Yeah, why is the?
Because the major axis is horizontal.
Just to follow the figure.
Yep.
So like if the x bigger, then you would go that one first,
Mm-hmm.
and then you would keep the y.
On the last one that we just had, though, oops, let me go back to, though the number underneath the y was bigger. So the major axis was vertical. So I had to add it to and subtract it from the y part. On this particular one, the number underneath the x is bigger, so it's stretched out horizontally. So my foci are going horizontal. Okay? Any other questions?
Oh, no, I think I got it.
Okay? So there is a video for you to watch tomorrow on the It's Learning. Okay? It will be short. We'll keep it under, or I should say. I will keep it under 10 minutes, I promise. Okay? There'll be more graphing type stuff. Good to watch, good to take notes on, etc., etc., etc. Okay? You are about to get the week 31 worksheet. I'll hand it out to you here momentarily. You can do the front side, numbers 1 through 6 on it. At Homer's, it is on It's Learning for you to print out and or just copy off of there. Okay? On top of all of that, we were just under 50% this past weekend. I got 21 homeworks and 24 quizzes, okay, which made it be 45. Okay, and actually I think we're just above because I had a couple people turn them in, physically turn in the worksheet. So we were right at about 50% of stuff this weekend.